Today we're going to be talking about scatter plots. So first we're going to talk about how scatter plots are different from previous visualizations. So because of that, we're going to go over a little bit about what those previous visualizations all have in common. Then we're going to compare and contrast those with scatter plots. And finally, we're going to go on to describing the different aspects of a scatter plot versus those other distributions we've been talking about before. All right, so the previous distributions we've really been talking about have largely been about frequency distributions. And here we're really talking about just one continuous variable, like height or age or number of friends on Facebook. And then we're asking, how frequent is this value? How frequent is it to have 200 friends on Facebook? How frequent is it to be 6 feet tall? Now, that frequency distribution, it looks like there's two variables because you have an x-axis and a y-axis. But really, it's one variable, height, and the frequency, which is not really a variable. It's just sort of counting how many of that height you have. But we have looked at some cases where we compare two different variables. But usually, it might be comparing two groups on some continuous variable. So we might compare male and female heights. But really, we're only looking at one continuous variable, height. The other variable is a categorical variable, the two groups, right? That's how we get the two groups, something like gender, right? And so although we have that, still the fundamental basis is that we've really only been looking at one continuous variable at a time. Now, these frequency distributions, we've drawn like histograms and different things. They often look like this, and they're summarized by shape, center, and spread. And usually by center, we mean something like mean, and by spread, we mean something like standard deviation. Now, that's going to be sort of the past. Now we're moving on to scatter plots. So here's how scatter plots are different. Now, instead of having one continuous variable, we have two continuous variables. That's the big key difference. And because of that, one axis is going to have, variable 1. And instead of putting frequency here, we're going to put variable 2 here. Whereas in frequency distributions, we had variable 1 here, and then we had that frequency of variable 1 here. Notice here there's no explicit representation of frequency. There's no number that we're plotting to represent frequency. And each axis is going to represent a variable. And we're summarizing these distributions by shape, trend, and strength. Here it's going to be called a scatter plot because each case is now going to appear as a dot. And each case, for instance, each person on Facebook might have variable 1, number of friends, as well as variable 2, how many photos they've uploaded, right? And so each dot represents one person, but two variables within that person, two values within that person. And because of that, it's called this scatter plot because it could look like somebody just scattered a bunch of dots on this graph. So it makes sense why it's called a scatter plot. Notice that here, it doesn't quite seem like we're really interested in the center of one dimension. We're sort of interested in the center of two dimensions. And so because of that, trend is going to be sort of like center, and strength is going to be sort of like spread. Sorry. And so these concepts are concepts you've thought about before, but we're translating them from one dimension to two dimensions. And so spread used to be something like this, but now we're talking about spread in two dimensions. And that's going to look a little bit different. All right, so let's talk about these particular summary values of shape, center, and spread. And remember, frequency distributions are always what we call univariate in terms of continuous variables. It might have two variables, but one will probably be categorical. So when we talked about shape, we talked about things like unimodal. Is it symmetric? Does it asymptote? Right? So those are kind of the features that we were looking for. Is it sort of normal? Is it uniform? Right? Those are words that were sort of buzzwords when we talked about shape in frequency distributions. In scatter plots, we're largely interested in a couple of different shapes. One shape might be that the dots sort of fall in a line, right? So is it a linear scatter plot, right? Another potential distribution is that the dots might fall in sort of a curve. So is it curvilinear? And the final it's sort of a shape that we're interested in is maybe there's just sort of no shape and it's sort of blob-like or cloud-like, right? And this isn't sort of an official word, but, you know, cloud might be one way of thinking about it. So those are sort of different shapes that we're sort of interested in. How linear is it? Is it curvilinear? Is it just a big cloud, right? Now let's talk about center. The way we talked about center before was that we were interested in things like the mean, median, and mode, right? And a lot of times we use mean, either signified by mu or x bar, depending on whether you're in a population or sample. Trend really has sort of the same idea as center. So you could think about this as a version of center, except it's a center of two variables, not just one. And here, it's not really useful to have a center just dot, right? Because that's what we had before. We had a point mean, so it was like a particular point. But now what we're interested in is, let's say we have a whole bunch of dots scattered here. What we might be more interested in is a line of some sort that describes the relationship between all these points on these two variables, right? So here, we're not just interested in a point center, we're interested in sort of a line center. So I'm going to adjust this to be line center rather than a point center. And that line is going to be called, the official term for that is regression. So that's going to be the regression line. The final idea I want to talk about here is strength. And I want to sort of tie that to the idea of spread that we talked about. Before, one important idea of spread that we frequently talked about was standard deviation, expressed as sigma or expressed as S, big S. Let me write that a little bigger, right? So those are sort of two ways we've talked about spread before. And that gives you a one-dimensional spread. But what might be more useful here is something like a two-dimensional spread. So here we have our dots, we have our line. But now we're interested in how spread out these dots are. And so you could think about it as all these little distances away from that line. What's that spread away from the line like? And so you want to think of this as a multi-dimensional spread. It's not just a one-dimensional spread. It's a two-dimensional spread. So you could think about this as, you know, spread around line, right? So before this was spread around a point, but now it's a spread around a whole line. And we're going to call that correlation. And so if it's very strong, it means that it sort of hugs that line really closely. So that's a strong correlation where it hugs it closely. A weak correlation means it's sort of hazy, like it's sort of very, very far out and spread out from that line. And a moderate correlation is there's a little bit of spread, but not too much. And all of this has changed because now we're talking about bivariate distributions. And when we're talking about bivariate data, we're no longer just interested in points and spread around a point. We're interested in things more like lines. Let's move on. All right, so here's an example scatter plot. Remember that data that we've looked at in the past with 100 friends on Facebook, and we wanted to look at whether the number of friends people have sort of correspond to the year of birth. Now, this is not saying that there's lots of people necessarily born in 1997, right? This is not what this means. It means that this, right here, this dot, is actually a particular person. So it's a case of one person. And this means that this one person was born maybe in 1993. But they also have an inordinate number of friends. So they have, like something like 1,900 friends, right? So that's what these scatter plots mean. You can't interpret this as being a very popular year to be born anymore. Now you have to say, this particular person was born in this year and has this number of friends. So if you look at another point, like this one right here, they have very few friends, none actually, but they're born in 1978 or so, right? And one thing you might notice about this is that there's sort of this shape here. It seems to rise almost, right? So if we drew some sort of line that would cut through this, maybe it would be a line like this, where these people, they're as you see the year of birth increase, so these people are sort of younger, right? They were born more close in history. They seem to have slightly more friends, right? And if you drew a curve to sort of fit this, that might actually be better, right? Where it seems that, the people born, up to 1985, they have a relatively lower number of friends than the people born sort of afterwards. That seems to shoot up more. So this is an example of a scatter plot, and these lines are example sort of rough lines that might be regression lines that sort of fall in the middle of all these points, where these points are sort of roughly below it, these points are roughly above it, and if you counted all the distances up, that would sort of average with that line. And so let's think about that as the trend. So that's that trend. And the strength is that it seems maybe moderate strength. It's not hugging the line quite closely, but it's not just this amorphous blob either. All right, but usually we don't plot things by year of birth. I mean, sometimes we do, but you could easily change year of birth into their age, right? By just using 2011 minus whatever their year of birth was. And so here I have age plotted on the x-axis, and here I have year of birth plotted on the x-axis. But on the y-axis for both of these graphs, it's their number of friends on Facebook. So these are scatter plots, and you could know that just by looking at these two variables. If one of them says frequency, right, then you know it's not a scatter plot. But if they're both variables, then you know it's a scatter plot. Here we see sort of this this positive association. The higher the year of birth, the the higher the number of friends, right? So as one variable gets greater, the other variable also seems to increase, and vice versa. As one variable gets less, the year of birth gets less. The number of friends also seems to be quite low. On the other hand, if you look at this graph, we see sort of the exact opposite trend, where as age goes up, the number of friends seems to come down. Now, so they're sort of moving in opposite directions. As one variable goes up, the other variable is coming down, and vice versa. As you go down in age, as you go sort of this way on the x-axis, then you see friends sort of going up, right? Now, this is what we call a positive association, where the variables are sort of coupled to each other in the same direction. So we'll call this positive association. But when we plot age instead of year of birth, we see a negative association. So we mean negative here, not as in direction like going up or down, but negative as in they're linked in a way that's the opposite of each other, because negation also means opposite, right? So as one goes up, the other goes down. As one goes down, the other goes up, right? And it's important to note that these are just associations. It's not that the year of birth is causing them to have more friends. Maybe it's some other variable that matters, like when you were introduced to Facebook or something like that, what age you were introduced to Facebook, or how comfortable you are in using the computer. So just having a positive association doesn't mean there's a causal association, and that's where you get that famous saying, correlation does not equal causation, because another word for this association is also correlation. So just because you have this nice association, either positive or negative, it doesn't mean that they cause one another. All right. And let's think about why year of birth has sort of the exact opposite effect of age, right? Has the opposite association with friends on Facebook. Well, if you think about year of birth really means that when you're increasing the year of birth, you're decreasing the age, right? So these two variables actually have a perfect negative association, right? As one goes up, the other goes down. So as year of birth goes up, 1994, 1999, 2000, right? The age is going down and down and down. And so that's what we call a negative association. Now, it's not really that one is causing the other. They're sort of the same idea. So they're perfectly negatively associated. And that's why correlation or association does not equal causation.